Welcome to today's session or class or anyone, whichever one we call it, it still works. So today we'll be jumping into writing tests with Cairo and all. I'm sure you guys already know how to write Cairo smart contracts. True or true? Yes, Chinonso, your hand is up. Let me hear you.
Yeah, we are good to an extent.
Okay.
Yeah.
All right. You'll be better when you write more contracts. So the more contracts you write, the better you become. All right. So without further ado, let's dive in. So I'll be sharing my screen now. So we move right straight into it. Yeah. All right. Can you see my screen?
Yes.
Okay, great. So let me move into this slide sharply. Sorry, I didn't change this stuff. Let me quickly do it here now. This is December 11. All right. Okay. This is session 6, right?
Yeah.
All right. So this is the slide I made for one other stuff I did. So it's the same thing. So we can just use it. All right. I'm going to move pretty fast in this slide because the main heavy lifting is in the it's in the practical session. Sorry, let me move this so that I'll be able to see you guys. Yeah. So the main stuff is in the practical session, and also that's where we'll be more focused on. So I'm going to change this to slide now, slideshow. All right. Okay, so Cairo Bootcamp session 6, testing in StarkNet. My name is Katwini Ojukwu, and on Twitter, I'm Coding Cas. So yeah, Katwini Ojukwu, software. I'm just a software engineer, nothing else. Mostly focused on blockchain. So yeah, like I said, Twitter Coding Cas. And I like using these guys. Those of you that have seen Squid Game, I'm one of those faces behind that Squid Game. I participated in that movie. So this is how I like to present myself online. All right. So today's agenda, this is what we are going to be doing. We are going to be looking at what is testing. We are going to be looking at the categories of testing. We are going to see why testing is important. We are going to look at the tools for testing on StarkNet. And we are going to move into live coding session, which is like the proof of work. Then we are going to test. So these are the things we are going to do. We are going to write, there's a difference between StarkNet smart contract and Cairo programs. So Cairo is a language that is not just tied to StarkNet. You can use Cairo to write programs that are outside StarkNet. Then you can also use Cairo to write StarkNet smart contracts. So we are going to write tests for a very simple Cairo program. And we are going to also write tests for a setter, getter contract. Then we are going to write tests for an ERC20 contract. So I don't know. This session is supposed to be how many hours, please? I don't know if how many hours is supposed to last.
3 hours.
3 hours. Awesome. Okay. I think we can also do the bank contract if time permits. So then we look at the assignment. All right. So session 1, what is testing? So here we go. testing. So I'm going to be defining testing in the general sense of it, not just particular to smart contracts. So testing cuts across different areas of life. For instance, when the guys that built the Tesla cars finished building it, they had to test it to be sure it's working and all of that. So I'm going to be defining testing in the general sense of it. So testing is a process of evaluating a system or its component to determine whether it meets specified requirements or expectations. So before you write a test, you should already have something in mind. For instance, when you're writing tests for your smart contract, let's say you created a function that adds two numbers together. If you put the number A and the number B, let's say you use 2 and 2 together, you're going to write your test to assert that the result is 4, which means you're expecting 2 plus 2 to give you 4. So you're writing a test to assert that what you're getting is equal to what you expected. So that is why we have this definition. So you're testing something to ensure that it meets the required expectations or the specified requirements and stuff like that. So the main goals of testing are to identify defects, verify functionality, and assess the overall quality of the system. So when you're writing tests or when you're testing anything whatsoever, you want to test to ensure that, okay, this stuff you're testing, it's effective and the functionality which you built, it's working the way you intend for it to work. I want to do a general assessment of the system you're testing and all. So coming back to the okay, let's look at all those cars that don't require drivers. If they finish building it, they need to test it to be sure that, okay, this thing will not go and kill people on the road. Do you understand? So they might keep certain obstacles to see if the car is going to hit those obstacles. So this is testing in the general sense of it. So as we move forward, we are going to streamline it down to smart contracts. All right. So the next guy we have is categories of testing. So these are some of the categories of testing. There are a number of ways to test smart contract or StarkNet. There are unit tests, there are integration tests, end-to-end testing, force testing, and fork testing. We are going to go into details. Now let's look at unit tests. So unit tests involves testing individual functions or components in isolation. So for instance, let's say you have a smart contract that is made up of 10 functions, 10 different functions. Now, when you test one particular function, when you test one individual function, that function in itself, that is a unit test. Sometimes you might have different assertions inside your function. Let's say you want to assert that the person that is calling the function is the owner. So you can test for only that assertion. For instance, you can test that this function reverts not owner. You can test that this function emits event. You can test different components inside one function. So when you test different components inside one function, or you test only one function in itself, that is unit testing. Now, if you look at the next point, say it's very focused and specific. Typically test one piece of functionality. So you're testing one piece. You're not testing everything together. Just one small component in your function, or just the function in itself. Then it is fast to run, because you're testing small components. Running unit tests is very easy, unlike integration tests that combines different functions. It helps you locate issues quickly and simple to debug. Very correct, because it's you can easily, when you're testing a function and you're testing that it asserts that the person calling it is not the owner, you know where to go because you're just testing one function. You get, unlike when you're doing integration tests. So we are going to see how integration tests can be complex. Now, Since it involves testing individual components, individual functions and its components, it is usually more because it constitutes the highest number of tests in your code. Now, what this means is when you're writing unit tests, you can write like 10 separate tests for one function alone. For instance, if your function has like 3 assertions, now you're going to write the test for the first assertion. Let's say the first assertion is to assert that the person calling this function is not the owner. You're going to write test revert if not owner. That's for that same function. Then you're going to write another test revert if the amount you want to withdraw is 0 for that same function. You're now going to revert if the balance of the person that is calling the function is less than the amount they want to withdraw. For that same function, you're still going to write another test to test if an event was emitted. Right now, you're writing 4 different tests for one function alone. So you can see that the test can be many because you can write multiple tests for just one function. That is how unit test is. Now we are moving to the next one. The next one is integration test. So integration tests, you can test multiple components that are working together. For instance, for those of you, I don't know some of you, how many of you do Solidity before Cairo? Now, if you've worked with ERC20 contract before, you will know that before you perform a transfer from, before you call a transfer from function, you must have called approve first. You cannot call transfer from when you have not approved the contract that you want to call the transfer from. So let's say you want to test, a staking contract. Let's say you want to test a stake function. In your test setup, you first use the ERC20 token to approve that contract before you now call the stake function. Now you see that you're not just testing the stake function. Here now, you have interacted with ERC20, you have called approve, you have called transfer from. Now, this is an example of integration test because you're not just testing one function, you're interacting with many other components that will help you to test that function. Are you guys following? If you're following, please let me see thumbs up. All right. All right. So integration tests, you don't just test one component. You combine many moving parts together just to test one function. You understand? So now we have mocking can be done when testing, when doing integration tests. Now, when we talk about mocking, in Cairo, we call it, in StarkNet in Cairo, we call it mocking. But in Solidity, when you're writing tests for Solidity smart contract, they call it prank. Where you want to prank an address, you want to. So I will stick to mock because we're talking about Cairo. Let's leave Solidity out of the equation. So you can mock an address to be the one that is calling a particular function. So for instance, let's say you created an address when deploying your contract and you pass that address to be the owner of the contract. And now you have a function that only owner can call. You can mock that owner address and use it to call that function so that it will not revert. So this can be done in integration tests. So another thing is integration testing are fewer. They are usually fewer. For instance, if I create an ERC20 token and now I want to test the balance of, the balance of function, it returns the balance of that token that the user holds. I want to test the balance of function. Now, before I test the balance of, I will first of all mint that token to the person I want to check the balance of. Now, if I mint the token to the person and I test the balance of, is there need for me to test mint again? Because if the mint didn't work, balance of wouldn't have worked. So in one function, I've done mint and I've tested balance of. So there's no point testing mint separately and testing balance of separately. So the test for integration test can be fewer. You understand? For instance, if I want to test the transfer function, I'll first mint to the first user, check if the balance of the user increased, then I'll transfer to another user, then check if the balance of that other user increased. Now, inside that transfer function that I want to test, I've used mint, I've used balance of, and I've tested transfer. Why do I need to test balance of and mint separately again when I've already done everything in one test? So you can see in this case now, one test has covered 3 other tests that I would have done separately. That is why they say it has fewer tests than unit tests. Now, it verifies interaction between different parts of the system. Yes, like I said, when you want to stake in your contract, you have to approve that contract first before you stake, because the stake function is going to make use of transfer from. So in that one test, you have interacted with the ERC20, you have also interacted with stake, because these are different components of this particular smart contract. Now, it's slower to run, yes, and hard to debug, because some integration tests can be very large. And most times, if there's an error, you might not be able to pinpoint where the problem is coming from. So what I basically do in cases like this, I'll comment out the whole code in the test. I'll start uncommenting them one after the other to find out where it is getting the issue from, because it can be hard to debug based on the fact that the code can be large and you're interacting with different parts of your contract, so you don't know the exact place that is failing. It's slower to run, yes, because when you're interacting with different parts of your contract, it's before you interact with the ERC20, comes back to the staking contract, it can take a lot of time for it to run. It represents real world usage more closely. Now, for instance, let's look at this. Let's look at the real world usage of a staking contract. You connect your wallet, you click on stake function, your wallet pops up for you to approve the contract. When you approve the contract, your wallet pops up again for you to sign the transaction to stake. Now, when you're writing a test for stake, first thing you do first is you mint token, making sure that the person has the token. Then you approve, which is the same thing your wallet would have done. Then you now call the stake, and the stake will do the transfer for you. This means it is representing a real-world scenario of what users would do if they were interacting with your decentralized application. So this is for integration test. Now let's move on to the next one. The next one is end-to-end test. So end-to-end test application from start to finish, simulating a real user's journey. So end-to-end test is like you're simulating how someone will use the application from point A to point B. And when you do that, you're simulating a real user journey. For instance, let's say you have a contract, or let's say you have a contract whereby users need to claim an NFT. But before they claim that NFT, they need to deposit a particular token to ensure that they have some amount before they claim that NFT. So first thing user will deposit. When they deposit, they now proceed to claiming an NFT. So in such cases, what you do is you're first going to mint token to user, you deposit before you proceed into claiming an NFT. This might be the entirety of what someone can do in that contract. So end-to-end test is basically like simulating the point A to point Z of your application inside your test case or your test scenario. So it involves testing the complete system, including all components and interfaces. Yeah, some end-to-end tests might involve user interface like front end and all of that. So it can be a lot cumbersome to set up. So focuses on how the UI system integrates with the smart contract. Slower and more complex to set up than unit and integration test. So this one is just straightforward. Now, force testing. So the aim of force testing is to find problem in your contract, to find breaking points or security vulnerability in your smart contract. So I'm going to give you an example of how this force testing can be. Let's say you have a function. That function takes in an argument, or the function takes in an argument of unit 8, right? Now you want to test that function to see whether if someone passes a unit 256 into that function, whether it's going to break. So what you're going to do, you're going to force test that function. And force testing that function means the system will randomly generate numbers and be loading it to that function to see the number that is going to break that function. Now, let's say a function is supposed to return, for instance, you create a function that adds two numbers together. Now, the function takes in two arguments of UIN 256, right? Two arguments of UIN 256. Argument 1 is A and argument 2 is B. Now, you know that function is going to return UIN 256 as well. But when you add the highest capacity of number a UIN 256 can hold and the highest capacity of number a UIN 256 can hold together, you know the number is going to give you more than UIN 256. So force testing is used to test such kind of scenario. For instance, we know the max number UIN 256 can hold, right? So if you add two of those numbers, normally your function is supposed to return UIN 256, but if you add two of those numbers, it's supposed to, the number it will return is supposed to be greater than UIN 256. So force testing tests such breaking points to test where this function can break, find vulnerability and crash points and all of that. So, like you say, it aims at finding security vulnerability, crash points, and unexpected behaviors by feeding garbage into the system. Inputs are generated automatically by a fuzzing tool rather than manually. It complements other testing like unit tests and integration tests as it focuses on edge cases and failure points. So what force testing does is just focuses on where this function is going to fail. So it's looking for failure points in your functions and all of that. So the next thing we are going to look at is fork testing. So fork testing is very, very, very important, especially if you're going to be writing smart contracts that will be interacting with already existing smart contracts. For instance, let's say you're writing a smart contract, you're building a platform where users, so you're building a platform where users can buy stuffs with any amount of money, with any token. Users can buy stuffs on your platform with any token, right? But the prices of your stuff, of your items on that platform are in USDT. Pay attention to this scenario I want to give you. So the prices of items on your platform are in USDT. But users, you want users to pay with to buy things with any token, whether a Stark token, whether brother token, whether sister token, whether a Kubo token, and all of that. You want users to be able to buy with any of those tokens. But prices are in USDT. Now, how do you handle such cases? Now, in such kind of scenario, what you're going to do is users will bring, when users want to pay for something, under the hood in your smart contract, you're going to calculate the amount of token that user, that is required of that user for that USDT value. For instance, let's say I want to buy shoe, and shoe is 500 USDT. but that user wants to pay with a Kubo, right? Now, your smart contract is supposed to give the user the 500 USDT equivalent of a Kubo that the user is supposed to pay. Now, how do you do this? You're going to make use of a decentralized exchange smart contract. You're going to interact with a decentralized exchange smart contract to handle this scenario. And inside your contract, you're going to interact with a swap that will swap a Kubo to USDT and give the vendor their own money. Now, if you want to test such kind of smart contract, how do you test it? Since the contract you're interacting with is on-chain, is deployed, but you want to test it in your local system. Now, this is a scenario where you make use of fork testing. What fork testing does is it creates a copy. It creates a copy of your on-chain, of what you have on-chain in your local system. So when you're testing, it is testing and interacting with the on-chain contract as if it is in your system. Although no changes will be done to the main one on-chain, but it's going to interact with it as if it's in your system. So you're forking what you have on-chain into your local system, and you're using it to test your smart contract. That is what fork testing does. So we can look at all these bullet points I have. I just want to give you like a clear explanation of what it means. Bankers, don't worry, I will get to your question. Let me just finish explaining all of this. So fork testing, it involves creating a duplicate or fork of a live production of a live production like environment for testing purposes. Allows developers to test changes without impacting the actual production system. So the testing you're testing, for instance, you can test swap in your smart contract. The swap will work perfectly, but it's not going to change anything on chain. That's what this second bullet point is saying. The third one is it mirrors the real world condition as closely as possible. You know, you're going to interact with a real world smart contract, so it mirrors it as close as possible. It's a more comprehensive. So fork testing is also an integration test because you're interacting with different components of the smart contract inside your test. So it's also an integration test. It's a more comprehensive integration testing compared to just running tests in a local environment. It helps identify issues that may only arise in a real-world production-like setting before deployment. All right, before we go to white test, now let me see the questions we have here. So Banker said, is this similar to setting up a staging or quality assessment environment to test? No, this is you don't need to set up any staging environment. This is not staging. So staging is basically when you're building stuff that has to do with backend. Yeah, when you're building stuff that has to do with backend. So you have your staging server and you have your production server. So staging is where after building, when you're done building your stuff, you push it to your staging server, test it on your staging server as like users will use the app. Once you're comfortable with what you have, you now move it to production. It's different. Fork testing is you creating like a copy of your on-chain, like what you have. So anytime you're interacting with a smart contract that is deployed on-chain, you have to do fork testing. Yes. For instance, let's say, for instance, let me give you another example. Let's say you have a contract where people can stake, but the criteria for staking is that users must have a Bored Ape NFT. I don't know how many of you know Bored Ape NFT, or how many of you are familiar with NFT. There's a very popular NFT called Bored Ape. So you want the only people that can stake in your contract must have Bored Ape NFT. Now, in your contract, you're going to declare a state variable where you're going to set the contract address of board A. You now write in your state function, you now assert that the balance of the person, the board A balance of the person calling that contract is greater than 0. You understand? Which means the person has a board A NFT. Now, if you want to write test for that contract, when you know that in your local testing, there's no how you can own a board A, you have to get an address of someone that owns a board A on chain. You're now going to mock that address. You're going to fork mainnet, mock that address, and use that address to test that staking function. So that is how you do forking, fork test. You can do mainnet forking, you can do testnet forking. So that is for, yeah. All right. So let's look at why test. Any other question before we proceed? Any other question? All right. Please ask me question, because there are some things I might not say or remember, but when you ask me questions that are specific to those things, I'll be able to break it down. All right. So why test? Let's see why you should test. So one of the reasons why you want to test is to identify and fix bugs. Yeah. So there was one smart contract that I was working on, I think in Odiak, I think Odiak 9, yeah. The guys have already deployed the contract on testnet. But while I was writing tests for the contract, I now saw a bug in the contract, right? And I called their attention to it. They now had to fix the function I was testing, and I rewrote the test. So testing helps you to identify and fix bugs. Testing also helps you to identify and resolve security vulnerability. I hope you know that not all bugs are security vulnerable. Some bugs will just make users not to use your contract, while some bugs are security vulnerable. For instance, any bug that someone can hack and move your money, that's security vulnerability. So writing tests can help you identify and resolve security vulnerability because money is involved. I hope you know that anything that whenever you're dealing with the blockchain, almost everything that deals with the blockchain is money. I hope you know that, because for everything you're doing on the blockchain, you're either interacting with ERC20 or you're interacting with NFT, or either minting ERC20 or you're minting NFT, unless you're building something, all this legacy decentralized application that has nothing to do with NFT and ERC20. But anything that has to do with NFT and ERC20, that's money you're dealing with. And you have to be careful, because if someone steals one of those NFT, they have stolen your money. So testing also helps you verify that the contract works as intended. Like I said, when you write a smart contract, you expect it to work a certain way. So when you write your test, you want to ensure that the contract works the way you want it to work. Testing helps you ensure correctness and reliability of your smart contract. Now, there's this joy, there's this confidence that comes when you test your smart contract, right? If you finish writing your contract and you test it, let's say you're working with a front-end guy. You know, front-end people can be very, I don't want to shade anybody, but front-end people can be very annoying. So let's say let's say you're done writing your smart contract. You're done writing your smart contract. You've tested it and everything, and you now give the front-end guy the API and the contract address. And the front-end guy want to do one manipulation, one array manipulation, and the guy cannot do it. He will now call you, hey guy, Alpha, how did you write this function? Now this your contract is not working. The function is not working. You understand? But when you've tested your contract and you know everything is working, you'll be like, guy, now you know sabi wetin you dey write. I've tested this thing, everything is working very well. You understand? So testing your contract gives you confidence because you've ensured that everything is working and is reliable. If you like, when the front end guy go talk anything when he likes, he has to conform because you've tested your contract. Then testing your contract builds confidence as a developer. Yeah. So when you know how to write tests, see, when you write your smart, there's a different joy you get when your contract is compiling, and there's a higher level of joy you get when your tests are passing. Let me explain. When you write your contract and you compile, everything compiles, be like, it's compiling. But when you now write tests and you test all your function and you run the test and you sit down and when you run tests, you first fold your hand and be looking at your terminal and you see first good, second good, third good, and you see 10 tests passing. It gives you this level of joy and fulfillment. You feel fulfilled. So writing tests builds your confidence as a developer and it makes you stay joyful. In OD hack, many people are running from tests. Me, that is where I like to go because I know people are running from it. I'll just go down, take chair and sit down and just be writing tests and be collecting money. So let's proceed. Now, testing tools. So for the purpose of this class, the only tool we'll be looking at is the StarkNet Foundry. And StarkNet Foundry, for those of you that came from Solidity background, you know about Foundry. So on StarkNet, the equivalent to that is StarkNet Foundry. And StarkNet Foundry, what we use in writing tests is, in testing, in running our tests is SN-Forge, right? So, and one of the reasons why StarkNet Foundry and SN-Forge are very cool is because they have some beautiful cheat codes and like out of the box cheat codes that helps you to test your smart contract seamlessly. Like you can automatically, you can prank an address and use it to call a function. You can stop the prank. You can, do a lot of things. For instance, on StarkNet, when you're writing Cairo, block.timestamp is always 0. So if you're coming from Solidity background where block.timestamp gives you a number, it gives you Unix time from within January when it gives you that Unix time. But in StarkNet and in Cairo, block.timestamp is 0. Now, if you wrote a contract that is making use of block.timestamp, you have to manually simulate a block.timestamp for it to work. So StarkNet Foundry gives you such tools to handle all of that. All right. So we are now in the time of truth. This is where we are going to start writing codes. And yeah, session 5. And let's look at how we are going to do it. So let's code modus operandi. So these are the things we are going to do. We are going to, first of all, right? So the way I like to teach testing is I don't just go into the complex stuff, like just start teaching you how to write tests for ERC20. I like starting from the ground zero, like 000 level. So we'll test the most simplest program you can see on Cairo. Then we move into testing something like a little bit higher, but not very big, like basic setter getter contract. Then from that, we'll move into testing and ERC20 contracts. I think the session was like we should test the ERC20 contract. So, but the bank contract is like a bonus. So if maybe I'm not too tired, I can just touch the bank contract. How do we go about testing smart contracts that rely on some other Oracle services? You can now, Shay, if you want to interact with Oracle, won't you get all those? There's how they do it then that we're testing Solidity contract with with Chainlink. You're going to interact with Chainlink, and there's a way you connect to Chainlink in your contract. So you're going to simulate it. Anything, you simulate all of them in your contract. Don't worry. When we are done with this testing, you can write something like which contract, an auction contract. An auction, is it? No, not auction contract, a lottery contract. Yes, lottery. Can write a lottery contract that will make use of for Cairo and StarkNet. You're going to make use of Pragma. Pragma is the oracle you can use. Pragma is to StarkNet Cairo as Chainlink is to Ethereum Solidity. All right. So this is how we are going to do this stuff. So here we are. We are going to start coding. All right. So give me. I'm going to exit this now. Yeah. So we are going to go into action right now. So let me minimize this guy. So I'm going to create a folder here, and I'll call that folder block fuse. I'll call it block fuse Cairo. No, block fuse StarkNet. So yeah. All right, so this is where we are going to do our stuff. So just give me a moment. Let me take water. Yeah. Just a minute. All right, I'm back. So let's get to work. So the first stuff we are going to be testing is we're going to write tests for a basic Cairo program. This is not StarkNet contract. This is just a Cairo program. So I'm going to go into this folder. I'll create a new folder. I'll call it Cairo _program. Now for this one, I'm going to right click. So there are two ways. There are two ways to create a project. In StarkNet. So one of the ways, let me show you one of the ways to do that. So I'm going to open a terminal on this block fuse folder. I'll come here. Now I'll now do scab new Cairo. Sorry, I know this thing is small. Let me make it big before I continue. 1, 2, 3. So I'll do scab new Cairo _program. I'll press enter. So it's going to give me option. Now, because I don't want to make use of StarkNet contract, I just want a Cairo program. I will not use StarkNet Foundry. I will come down here and I'll use Cairo tests. And I'll click enter. So it has created a Cairo program for me. So let's check it out. So I'm going to close this terminal. If I open this folder, this is the Cairo program here. So let's open it. So I'm going to do code here, and I'll open this guy. Now here we go. So this is it. Now, this is a Cairo program, not a StarkNet contract. The way this is now, you can use it to write programs with Cairo that are not necessarily going to be on StarkNet, right? So, and this is our lib. So this lib now is just, so you see that we have a main function here. In StarkNet contract, you don't have main function. This is just like the way Rust is. If you create a Rust package, you're going to see main function. Main function is the entry point. That is how this Cairo program is. Main function is the entry point for it. So this is not StarkNet contract. Now, I want us to write a simple function. Let's write a function. Let's call this function. Let's call it fn add. fn add. So this function is going to take what is it going to take? It's going to take a of type U256, and it's going to take b of type U256. And since this function is going to add two numbers together, you want it to also return U256 and kill this guy here. Now, there are two ways to return stuff in Cairo. You can either do return A plus B, and you end this guy like this. This works, but me, I don't like the syntax. I prefer the other one. I'll just do A plus B without semicolon. It's the same thing. Now, inside this main, I'll just put add here, and it's crying, which means it's expecting two stops. I'll put 20. Why are you crying, bro? Why are you crying? Why are you crying? Add. Let me see why it's crying. Expected core integer. Okay. So this guy is returning U32. Meanwhile, what is here is U256. I don't know if you're getting. So if we change this to U256, we are good. We are good. Now, let's now write test for this. So pay attention. You see that these two functions are outside of this module, this test module. This is a module. When you see mod like this, it means this is a module, which means this main function and this add function, they are not in the scope of this module. But there's a way you can bring this guy into the scope of this module using the super keyword. So when you do use super means anything outside this module, super, then what are we looking at inside outside the module? We are looking for the add function. So we are going to bring the add. You see that we are good now. So that's it. So now we want to test. This is when you're writing test in Cairo, all your tests are inside a function, and that function will have an attribute test. So you see this attribute now that is on line 13. Let me zoom this guy in. So you see this attribute on line 13. This is what is telling the compiler that this function is a test. So it's going to run, when you run your test, it's going to look for all the function that has this test attribute. That is what this test is signifying. So inside here now, we want to assert. Let me do add here, and I want to give this guy two numbers. I want to say 20, 16. So we want to assert that 20 plus 16. What will 20 plus 16 give us? 36. So we want to assert that when you add 20 plus 16, it's going to return 36. And if that fails, we are going to say it doesn't work. Or let's say it failed. That's the error it's going to return. So let's test this guy straight up. So to run this guy, I'm going to do scab test. Let's see. So you see that our test is passing. See that our test is passing, right? So this is checking that 20 plus 16 is equal to 36. If we change this to 35, it's going to fail because 20 plus 6 will not give you 35. Have you seen it? It has failed, right? Are you guys following? All right. So this is just a basic, this is Cairo program. This is not a smart contract yet. So let's keep this guy back to 36. So if we run this test now, it's passing and everything works. So if you look at this, this is our function. This add is a function, and that's what we are testing here. But if we want to run this stuff now, we want to run it to check. I think it's scab. Let me scab. Scab run. Let's see. There's no script. Wait to. How do they run this thing again? No, we write contract. We don't normally use run. We do scab build. There's build. Let me see. Scab. Let me do scab. If I do scab, this is how we find things. Yeah, it's going to show us all the commands that we need. So we're going to see scab, remove, build, expand, catch, clean command. This is no. Scab new, publish. Yeah, scab run now. Yeah, scab run. Run an arbitrary package script. Yeah. So scab run. Scab run. Sorry. Scab run. Okay, the reason why this, let's see, let's do something. Let me be sure that it's running. Let's do print ln, right? Let's do print ln. We say add returns u, and we come in and we now say add into 20, 16, right? Yeah. So it's supposed to print 36 for us. Let's run it and see. Scab run. I don't know what is scripts via scab run.
Cairo dash run.
You say?
Scab Cairo dash run.
Oh, scab Cairo dash run. Oh. Like this, Abby?
Yeah.
Okay. Oh, awesome. Thank you. Thank you. All right. So that is it. All right. Let's proceed. So this is the first guy we wrote test for. That's a basic Cairo program and all. So I'm going to close this. Let's move to the second guy. Whoa. Okay. Sorry, give me a moment. I've scattered everything in my system. Just a moment. Let me stop sharing. Arrange this stuff. Ew. What did I just do?
We can't hear you.
Oh, sorry. I thought I was. All right, let me share my screen again. Yeah. Can you see my screen?
Yeah.
All right. So let me create a new folder now. So this one we are going to work on a setter underscore getter, and we are going to write a test for it. So setter getter, yeah, here we go. So I'm going to show you the second way I create project. So this one, I'm going to open my terminal on that particular folder, and I'm going to, let me maximize it first. So I'm going to say scab. You know, the other one I did scab new, but this one I'm going to do scab init. Now do dash name, and I'll say setter getter. Yeah, and now this one now is a smart contract I want to create. So I won't use Cairo test, I'll use StarkNet Foundry. So I'll just press enter and it's going to create this guy for me. All right. So now that we have this guy, let me open it. Yeah. All right, so I'm going to close this guy. Let's go. One. All right, so this is our leave. Okay, so the contract we want to create now is a simple setter getter contract, right? That sets something to storage and reads something from storage. So the first things we are going to do, let me clear all of this. So let me quickly clear all this stuff, or we can just leave it. So first thing we are going to do is I'm going to change this interface. I'll call it iSetter getter. So I'll call it setter getter. And the functions we need is, so we want to be able to set a number and also read the number that we are setting. So we are going to call it set number, and set number is mutating, is changing the state, is changing the value in the state. So we have to make use of a mutable reference here. That's why we make use of ref self, immutable reference of self. And self here is a contract state. But here we are making use of T contract state, which is a generic. So this is for test. I don't want to go into talking much about Cairo and all those stuff, but this T contract state is a generic. And what we are going to take in here is a number. And we don't want this to be felt. We want this to be U256. All right. So this one is going to get the number. It's going to get the number. Since this is reading from state, we are making use of a snapshot. So this is a snapshot of the state. That's the contract state. And that's why you have this @ sign here. This @ sign here represents a snapshot. And now, since we are reading from the state, we want to return a number. So we are returning U256. Be good. Now, for storage, we are going to call it number. and it's of type U256, right? So this module, this is supposed to be the name of our smart contract. So we are going to call it setter getter. That's the name of our contract. So this is where we are now going to implement. We are going to implement this our interface. And when you are implementing an interface, it's going to ensure that you implement all the functions that exist in this interface. And just to stick to the naming convention, we are going to call this setter getter implementation. So that IMPL, that IMPL is the short form of implementation. So this setter getter implementation of super. Remember, I said earlier that this is a module, and when you want to access something that is not declared within the module, you make use of super. Let's say that stuff is not declared within the module, but it's declared inside the same file. You make use of super to access it. Now we want to access our interface. So we get our interface here and do this guy. Now remember that this interface here, what we're passing here is a generic. A generic is like a placeholder. It's not the main thing. It's like a placeholder that, okay, it's telling you that something is still going to pass in here. It's like it's a generic type. So, but the actual stuff we want to really pass into this interface is the contract state. And this contract state is what holds the state of this contract, this smart contract we are writing. From this contract state, we can access everything in the storage, we can access everything in the events and all of that. So that is what this contract state is. Now, this stuff is crying. You can see the red squiggly lines, the squiggly lines here. Sorry, I'm not going to bite my tongue. They call it squiggly lines. You know, you used to do like this, like W. So that's why they call the name squiggly lines. So it's showing these lines because the name here doesn't fit with the names here. So we are going to pick this and replace this. We'll call this set number here. And this is get number, and we call it get number here. And also the argument doesn't match. Let's remove everything inside this function first. I'll remove everything here. So the argument doesn't match. This is taking a number of U256. This is taking amount. So change this to number, and we do this U256. Okay, that works. You see that it's no longer crying. Why this other guy is supposed to return a U256 was returning failed. So we do U256, and we're good. That line is good, but this other one is throwing error. Reason is because you told it that it's going to return something, but the function is not returning anything. So for the meantime, let me just give it 9. Yeah, so we're good. Now, let's write our contract. So the first thing first, we have our number here. We have our arguments here. All we just need to do is self.number.write. We give it number. We're good. That's all. As simple as ABC. You see that Cairo is the simplest programming language I've ever written. So for this other guy, we want to read from state. All you just need to do, simple something, self.number.read. You see this language is just like English. You see this one, it says self. Listen now, self is saying self, me, myself. This contract is a self. What are you looking for inside this contract? Number. Are you getting it? Now, what do you want to do with number? I want to write something to number. You do the try, and what am I writing inside number? You pass in the number. Then the second one, self, me, this contract. What am I looking for? Number. What do I want to do? I want to read a value that is a number. As simple as, is this not amazing? This is simple something. So this is it. We are done with our setter getter stuff. Unlike other programming language that you will see equal to everywhere. So this one is just straightforward, read and write. Now we are done with our contract. If we do this guy, if we do scab, build, it's going to build perfectly. All right, we're good. Now let's go to the test. Now this one, we don't write the test inside here. This is a contract. We want to separate the test. We want to keep the test somewhere else. So we are going to enter our test folder. You see this test contract. This is where we are going to write our test. All right. Okay. So now, for us, for those of you that came from Solidity background, you know, there are an interface. What is this one? There are two use cases of interface in smart contracts. Two use cases. One of the use case of an interface is for implementation. And the second use case of an interface is for interaction. Take it anywhere. Those are the only reasons why you use interface in smart contracts. Implementation or interaction. Now, the first use case for interface is what we did here inside this place. This interface now, we are implementing what is in the interface. That was why we did this. So when you use interface for implementation, you must implement the functions which the function signatures exist in the interface. But the second reason why you're using interface is for interaction. If you want to interact with a smart contract that has been deployed, you know, when you deploy a smart contract, what you get is contract address. That contract address, when you want to interact with the functions in that contract address, you have to make use of an interface, use it to connect with that smart contract to interact with the contract. Now, for front-end people might not really use interface. They use ABI because the ABI gives you the same signatures as an interface. All right. So now, in our tests, because we are going to be interacting with that smart contract, we are going to deploy the smart contract first, get the contract address, and we are going to interact with it so that we call the functions in the smart contract. We need the interface. But in Cairo, whenever you create an interface in Cairo, the Cairo compiler automatically creates a dispatcher for you. That dispatcher is what you now use to interact with smart contracts. Yeah, anytime you create interface in Cairo, the Cairo compiler creates a dispatcher, an equivalent dispatcher for you. That is what you use in interacting with your smart contract. But in Solidity, it is the same interface. There's nothing like dispatcher. All right, let's continue. So I'll get rid of these guys. I don't need them. Now I need our interface. Let me see. Okay, the interface is public. So this is setter getter. And what I need is I setter getter. I need dispatcher. Dispatcher now. What's wrong with this one? Dispatcher. Dispatcher. So I also need the dispatcher traits. So I'm going to do this. I'm going to copy this, paste it here again, and I'll remove this trait from here and add to it. So I need the dispatcher trait. So I'll get rid of this line. I don't need it. Now we have our interface, our dispatcher. Now the next thing we need, I don't need this guy. I don't need this guy to take an argument, because now when you make this deploy contract take argument is if you want to use it to deploy different contracts. But I only want to use it to deploy. I'll just say deploy setter getter. Deploy setter getter. I don't need this. I don't need this guy. So what I'll just come now, what you're going to put here is the name of the contract. So I'll come here. The name of the contract is setter getter. I'll copy it. Go back here. Put it here. Now, once you deploy this guy for me, our contract doesn't have any constructor. Our contract doesn't have any constructor, so we don't need constructor argument. So this will do. So let me get rid of this other stuff here. I don't need all this code. We don't need them. We just need one code. So this test, let me get rid of all of this. So this test now, call this setter getter address. That's the address of our setter. I like naming it this way, because if you're dealing with so many contracts, don't name it like this, it will confuse you. So setter getter, I'll call this deploy setter getter. This is not taking any argument, so I'll get rid of this. Right. So once this guy deploys the setter getter, I will now say setter getter is equal to setter getter dispatcher, which is equal to contract address colon this guy. Now, the reason why they had only contract address here before was because this stuff, this guy here was named contract address. And there's no point doing contract address colon contract address again. Since both of them are the same name, you just leave it at contract address. You get? So that was why it was like that. But me, I'm not doing my own like that. So I'll keep it like this. So now we have gotten, this is our setter getter contract address, which we got after deploying this stuff. You see that this stuff is returning an address. Now, here now we are connecting, we are using this dispatcher to connect to the contract so that we can have access to the functions that that are contained in this contract address at all. So now that we have done this, I'm now going to say, so what we are going to do now is integration test. This is not unit test. The reason is because for you to test the get function, you have to first, the get number function, you need to first set the number. Or you can test the get number and assign that is 0. Then you now do, but there's no point. So we have to set the number first. Then call the get number to ensure that that it was properly set, and what we said is what we got. You understand? The only way we would have set number differently is if we were emitting an event. But now I don't want us to go too deep. Let's just take it one step at a time. So the first thing we are going to do, we are going to say setter getter dot set. So this thing is supposed to bring suggestion. The reason is because this compiler used to join sometimes. So this is what we are going to do to fix it. I'm going to close this guy and I'm going to open it again. The Cairo compiler, sometimes it will be misbehaving. It's okay now. And how I know whether it's okay or not is, I'll show you. Now, if you look at this declare, you see that this declare is showing blue, is blue color now. Anytime this declare goes to ash color, know that the compiler is no longer working. That's how I know. So I'll now say setter getter dot set. You see that it's bringing suggestion because the compiler is working. Dot set number, and I want to give it 10, right? Then I'll now come here and say, let contract number be equal to setter getter dot get number. So here I will now say assert that contract number is equal to 10. Else I'll say wrong number. So let's test. Scarp test. So you can use SNForge test, SNForge test. It will still run. All right, you see that the test is passing. Then you can also use scarp test. The reason why scarp test works is because when you come here, see under script, when you call scarp test, what it calls under the hood is SNForge test. This is it, SNForge test inside scarp.2mm. So when you do scarp test as well, it also runs. All right, so that's good. So if we come back to this test, let's say we want to check if we are doing the right thing. Let's change this to 11. This test is supposed to fail right now. Once we run test. You see that it has failed. And if you look, see what it sent, wrong number. That was what we asked it to send if the test fails. So put it back to 10. And so with this, we can see that the set number and the get number are all working perfectly well. Because if the set number wasn't working, the get number would have been returning something else and it would have been failing. So this is an example of integration test. This is not unit test. Unit test is if we were testing just one function. But now we are testing two functions in one test. So this is integration test. All right. So we are done with this one. The next test we are going to do is a lot more complex test. So brace up, guys. If someone is distracting you where you are, tell the person to stop because we want to move into a higher level of complexity. All right. Please, what is the use of dispatcher in StarkNet? I just explained this now. Were you distracted? I said dispatcher, once you create an interface, the compiler automatically creates a dispatcher for you. I said an interface is used for two purposes, for implementation and interaction. But in Cairo, what you use for interaction is that dispatcher, because it is the dispatcher you use in connecting with the contract address that gives you access to interact with the functions, that contract. All right. Okay, so we are done with setter getter. Next thing we are going to do now is we are going to write contracts for ERC20. So I'll come here, I'll create a folder called ERC20. Wait to open my terminal here. I think this is the last test you are going to do. I will not do the bank testing. So I'm going to do scarb init. I'll call it, what should we call this token? Which name should we call this token now? Let me look for someone for this call. Let's call it, I'm looking for someone on this call. I have simple name. Simple name. Simple. Okay, we can call it.
That's talking.
No, let's call it Bootcamp. Call it Bootcamp. So we say Bootcamp underscore token. All right. Yes, that will be the ticker, BNK. All right, so let me open it on VS Code. Yup. 1, 2. All right, it's gonna get. Okay, so how did you get here? I thought this bank card that we wanted to do. No. This is not what I want to. I want this thing now. What is this? How did I get the ERC20? I'm coming. How did I get? It's bank cards now. It's bank cards. All right. Okay. Yeah. So bank card token, here we go. All right, let's maximize this 1, 2. So there are 2 ways to create tokens it's not only in Cairo, generally, even in Solidity, there are 2 ways to create token. One is to write the token yourself and from scratch, and the second way is to make use of. So in Solidity, you call it open Zeppelin contract. In Cairo, you call it component, open Zeppelin component. So just the same way you have open Zeppelin contract in Solidity that you can just import and make use of the contract. In Cairo, you have components that you can just import into your contract. You don't need to write everything from scratch. I'm sure they've taught you guys how to make use of component or how component works. If they have done that, let me see it. Thumbs up, please. Yeah? Nobody's raising hands up. Only 2 persons. Only 2. You guys know components. So, all right. We are going to see how to make use of components now. We'll be making use of open Zeppelin components for building this guy. But for the sake of understanding, I'll be explaining the process as we proceed so that some of you can still follow through and get like how component works and all. So yeah, let's fire down. Okay, so I'm going to open this guy. This is our lib. So I don't want to confuse you guys by creating separate, separate files. So I'm going to do everything inside the lib file. So first thing first, I'm going to call this iBanker token. iBanker token, and the iBanker token, this is going to be Banker token, and this is going to be Banker token implementation, right? I'm going to get rid of all of this. I don't need them. I'm going to get rid of this guy in this storage. I don't need it. I'm going to get rid of everything inside this guy. I don't need them. So we have a clean contract structure. So now, the only function that this interface we are going to be implementing here is the mint function. The mint function, because every other function will come from the OpenZeppelin components and all. So I'll just say fn mint. And when we want to mint, first thing first, we need is a mutable reference of self, ref self. This is going to be the T contract state. That's the generic for the contract state, right? And when you want to mint something, you need the address of the person that you're minting to. So you say receiver or recipient, receiver, recipient. Which one should we use? Recipient. And the recipient is supposed to be of type contract address. And also you want to mint, you want to pass in the amount of tokens you want to mint to the person. So you put in amount, and this is of type U256. You end it here. Now we have not imported contract address. Contract address is a type that is not, it's a type that is not part of the Cairo standard library. So you have to import it. So you come here, you say use StarkNet colon contract address. Yeah. So we have fixed this guy. It's no longer crying. Now the next thing we want to do is this interface doesn't exist. So it's iBanker token that we want to implement here. Yeah. So, and you see this guy is crying because we have not implemented the function. Whenever you're using an interface for implementation, you have to implement the function that the interface exists in, the signature exists in the interface. So we are going to say fn mint here, and this is going to be ref self of contract state, and it takes in recipients of contract address, and it takes in amount of U256. Yep. And you open and close. But why is this guy crying? Because we still don't have contract address within this scope. So I'll just copy this guy and bring it inside here to be inside the scope, and we are good. Okay, step one done. Let's move to the next thing. Now we want to make use of OpenZeppelin components, right? So we need to bring in OpenZeppelin into our package. Now this whole stuff, you see this banker now is referred to as a package. So we have to bring OpenZeppelin into our package, and that will be done inside this place. So I'll just go and copy OpenZeppelin and put it inside the package for us. So OpenZeppelin, bring it in. So it's supposed to be under OpenZeppelin here. So it's supposed to be here under dependency. Yeah. So you can see I've added OpenZeppelin here on line 10. So we have our OpenZeppelin. This is, I'm using the version 0.17.0. So that is it. And I'm going to close this guy. Now, to make use of this OpenZeppelin component that we have brought in, my mouse is hanging. What is something? Okay. To make use of this guy, we need to import the OpenZeppelin component from OpenZeppelin. So I'm going to say use open. I need, see, when your compiler is active, life will be easy. So let me show you guys something. Let me quickly show you guys something so you understand. Hey. Let's go here. Let's go to GitHub. OpenZeppelin, yeah. Okay, OpenZeppelin contracts. Remember I said all those things are called package. So we'll go to packages. Inside packages, let me zoom in. Inside packages. Now what we are looking for is a token. So we are going to go to token. This is token. Click on it. So under token, inside the source, click on source. Now what we need is ERC20, right? So let's see ERC20. This is a component that we need. ERC20.Cairo. Okay, this is this thing. So let's hit ERC20 and ERC20.Cairo. Yeah. So you see that if you look here, let me zoom in. If you look here, see that this thing, they call it StarkNet component, not StarkNet contract. Unlike here, they call it StarkNet contract, but here it's StarkNet component. And whenever you call something a component, it means you can embed it inside a contract. So now, when you look through these components, there's something called embeddable. So let's go. You see here they call, this one they say embeddable as ERC20 implementation. That's not the one we want to embed. We want to embed the mixing. This one is embeddable as ERC20 metadata. Now look at what is happening here. Let me show you something. Let me use my laptop mouse. If you look here, you see that this one has total supply, balance of, allowance, transfer from, and approve, which are the main functions of an ERC20 contract. But it doesn't have name, symbol, and decimals, which means if you want to make use of name, symbol, and decimal, you have to embed this one separately, and you now embed this other one separately. But there's another one. Okay, this one now is camel case. This one uses total supply in camel case, not the one with underscore. Balance of, transfer from, all of them are in camel case. But now you see this one called ERC20 mixing implementation. It has everything: total supply, balance of, allowance, transfer from, approve, name, symbol, decimal, even the camel case. So instead of embedding those other ones one after the other, it is better we just embed the mixing that has everything. I will show you how to embed those other ones one after the other, but it's instead of that, just embed only the mixing that has all the functions together. All right, so let's go back to this guy. So now we want to import the component first. So you see the part. Look at the part. That's all the way I went down to this place till I got to this component. That is the part you use in importing it. So when you do colon now, let's wait for it to suggest something for us. So we are going to token. I'll use token. We'll do colon again. This compiler is slow. let's see. Where's its compiler is slow, but let's see E. So we go to ERC20, we go again, colon. And now what we need is the ERC20 component, which is this. Now there's another thing that you need whenever you're working with components. It's called the ERC20 hooks empty implementation. Yeah, we bring it in. Now, we have imported that component that I just showed you on OpenZeppelin, this guy. This is what we just imported. This component now is what we imported. And you know this component has all this other stuff inside. Then that second stuff we imported, let me show you. This is the second stuff we imported. This one now. This one on line 552. An empty implementation of ERC20 hooks. That's what we imported. So we have imported the two guys now. Now, the next thing we are going to do now is, wait, sorry, my mouse battery is there. Let me change it just shortly. It's turning off. All right, I'm back. All right, let's proceed. So, where did I stop? All right. So the next thing we are going to do now is, now we have imported this component. The component has been imported. But the next thing we need to do is to bind the component with our contract. So that binding, what that binding does is, when you bind the component with your contract, it's going to bind your contract storage with the component storage. It's going to bind your contract event with the component event. That is what we are going to do next. So these are the steps of using component. First thing first, you import the component. Second thing is you bind the component together. And to bind it, to bind it, you can say you embed it. Either you call it binding or embedding it. So that's not even embedding, that's binding. So you want to bind the contract to the components and all. So you can now use this, what they call the component macro. So once you type this component macro and bring the suggestion, you click enter, it's going to lay it out like this for you. And once that is done, the first argument of that component macro is the path. Now, the path is simply this OpenZeppelin token, like this stuff like this now, down to here is the path. Let me show you what the path is. From this point to this place is the path it is looking for. But you have already imported it. There's no point passing the entire path again. All you just need to do is pick this guy, this one, and put here. That is the path it is looking for. So it's asking you which component do you want to bind to this contract. So we are binding this ERC20 component. That's the first thing. Now, what is the second thing we want to do? We want to bind this component to this storage, to our contract storage. Are you guys following? If you're following, let me see your hands up. Let me be sure I've not been talking to myself. All right, nice. Okay, so we want to bind this component storage to our storage here. So what we are going to do, we are going to create a storage, this thing, ERC20 colon. Now this colon, we are now going to say this component, copy it, put it here, and we want to access the storage. Storage, what do they call it? Let's check. Let's see what they call it here, inside here. So what we want to access is this storage. If you see it is public, it's a struct, it's called storage. So that's what we want to bind. So now say colon storage is supposed to suggest this thing for me now. Why is this compiler doing like this? But whether it does that or not, that's its own cup of tea. So that is how you bind the storage. Now, what we have done here is everything inside this component. Please pay close attention. Everything inside this component now, we can access it through this storage. We can access this component storage through this ERC20 you're seeing here. That is what we just did. If you look here, you see this storage. We have ERC20 name symbol, total supply, this. All these things here now, we can access it in our contract through this guy. Now, anytime you bind a component storage, you need to make use of an attribute called sub-storage. So, because it's not the main contract storage, it's a sub-storage. So you say sub-storage, in bracket V0. So that is the guy you need to make use of. So now we have done this. So we're now going to pick this storage stuff, copy it, and put it here. You see? So this is what is happening. We created a storage here, bind it with our component storage, then set it to our component storage, then use this variable and bind it here. So you see that now this component storage is now binding with this ERC20 that the value is our component storage. That's one. The next thing we are going to do is the event. Let's bind the event. So we are going to create an event attribute. This is supposed to be test class. We are doing component. Bind event attributes. Come here. You do derive. Inside this derive, you drop it, and you do StarkNet colon event. Now, once you do this guy, so we create our enum and we say event enum. Now, our event, we are going to call it ERC20 event. And this is going to be our component. That's the event in our component. Our component, colon event. That is what we need there. And that's all. Now, once we do this, this is going to be with an attribute of flat. Yeah. So once we do this, just pick this event here and bind it here to this component. And that way, we are done with the second step. If you guys are following, please let me see your thumbs up if you're following. All right. So this is the second step of using component. So we are done with the binding. Now let's move over to the implementation. So now that we have binded the stuff, we want to now, for you to have access to those functions in the component, you need to expose them inside your contract. And to expose functions in a contract, you make use of the ABI embed V0 attribute. So we are going to say ABI embed V0. Then the next thing we are going to do, we are now going to say implement import ERC20 INPL is equal to now this component colon. What are we trying to get from here? We are trying to get the ERC20 implementation. Now this ERC20 implementation, we are going to pass our contract state to it. So, and that is it. But now remember that this ERC20 implementation we just did only has those 5 functions, I mean 6 functions I mentioned. It doesn't have the name, symbol, and decimal. So we still need to do this again for the second one. But this one now, we are going to use, let me call this, let me check the name. So the first one we did was this ERC20 info. If you look here, you see the name ERC20 info. So the next one we are going to do, see, it's already telling you that you cannot have duplicated ABI. That's because you have imported this one and you want to import this one. So it's seeing the same functions more than one. Like it has seen balance of, and you're still putting balance of again. That's why it's complaining. So the next one we want to get is the metadata, the one that has this one. So you put it here. That's all. So this one now, you call this one ERC20 meta data, or just call it metadata implementation. So this one now will make available the name, symbol, and decimal to in your contract. So that is all. We have done it. So with this now, we have access to our transfer from, approve, allowance, and all of that. Now, there's one more thing we need. When you want to, when you want to set the name and decimal or a symbol of your what's it called, of your token, you make use of the constructor in that contract. That's if it was Solidity. But in Cairo, there's a function called initializer. Let me show you. So if we scroll down here, this is an internal implementation. So this is the initializer. This is the function you call to set the name and the symbol. But now this function is not an external, it's not a function, it's an internal function. It's inside the internal implementation. So we need to bring in that guy to inside here. So for that one, we are going to say implement, call it implement ERC20 internal implementation is equal to this same component. Just pick it, bring it here. And what are you looking for? That's the internal implementation. Yeah, internal implementation. Yeah, that's it. Then you pass it, your contract state. Everything is just straightforward and you're good. So, we have to set the name of our token here. So we are going to create a constructor. I'll say this in bracket constructor, right? And I'm now saying FN constructor. Constructor is modifying state, so mutable reference of self, and this is going to be contract state, and we hit here. So what do we want to do with this constructor? Remember that because of this binding we did here, we can access everything inside that component through this place. So I'll just do self.ERC20, which is this guy, dot, what do we want to get? Initializer. Initialize. Our initialize function, initialize. Initialize also. Yeah, initializer. So what does our initializer function take? It takes in name and symbol. So we'll call this what's the name of this guy again? Bankart. We call this Bankart token. And what's the symbol that guy mentioned? BNK, yes. So for the symbol, say BNK, and we are good. So are you guys seeing how simple this thing is? Because of this binding we did here now, we can access everything inside that component that we imported. Because you see, self.ERC20, we can now get all the functions that is inside that stuff because of this binding. All right, so let's proceed. Wait, we have spent 2 hours, so hey, okay, let's move with speed. All right, so our token is set. Our token is set like this. But you see that with this now, we did ERC20, we embedded this one and this one. But if we embedded just the mixing, there's no point to embed these two anymore because the mixing has all those functions. So I can just come here and just get the mixing implementation. Let me get the name. That name, ERC20 mixing implementation. I'll just come here and put that mixing here. If you put it now, this one will complain. Watch. You see, it's complaining because the functions that are in this mixing, the functions that you're importing here are already here, and duplicate functions are not allowed. So this one is going to throw an error. It's telling you that fail to generate API, duplicate entry point name. This is not currently supported. You have seen it. So we are going to remove this now. We don't need it. So with that mixing implementation that we embedded, we have all the functions that we need. So we are good. Let's now move to test. Okay. Any question? No question. Let's proceed. All right. So we are in the test. So here now, same thing I did there is what I'm going to do here. I'm going to remove this stuff here. I don't need them. I'll remove them. I don't need them. So, but there's something else we need to do. There's something else that is very important that we need to do. So, you know that when we're writing this stuff, we only had this interface, right? This is the only, wait, I've not implemented this stuff. Wait, let's implement this guy. So for us to implement this mint, you know, mint, there's a, let me show you. If you go down to this place, watch. Let's go down to this internal guy. If you go down to this internal implementation, you can see that there's a mint function here. So that our mint function is going to be calling this mint, right? So that's what we need to just do. So inside here, we are just going to say self.erc20 we want to call the mint function in that place, .mint. And who do we want to mint to? The recipient that we are passing here. And how much are we minting? The amount that we pass here. And we end this guy. That's all. Like as simple as ABCD. So let's go to our test. Now on this test, remember that you need interface to interact with the contract. And now our token contract has many functions. Meanwhile, here we only have mint function here. Because if we use this Bankart iBankart interface, we won't be able to interact with our token because iBankart only has mint function. So we need another interface that has mint function and also all those other things. So I'm going to just copy one interface like that and bring it in. So just make use of it. So I'm going to, I don't need this. I don't need all of this. So I'll remove this. I'll just paste that interface here. So the reason is because we have to work with total supply balance of allowance, transfer from, approve, name, symbol, and all, and also the meet. So we need all these functions to be able to work. All right. So the next thing we have here is our deploy contract. So this deploy contract is going to take in the name of the token and it's going to deploy the contract and return the contract address for us. We are not changing anything in this function. It remains the same. Now the first, so I'm going to get rid of this text. This last one. So the first thing we are going to test, we are going to test the constructor. Now, this constructor we want to test. Remember, constructor is one function on its own. So if we are testing only constructor, that is what type of test. You can unmute your mic and talk. Hello.
Unit test.
Eh?
Unit test.
Very correct. So if we are testing only constructor, that is unit test. So we want to write test for constructor. So I'll call this test constructor. Right? So first thing first, we are going to first of all deploy our token. And the name of our contract is Bankers token. So I'll copy it and I'll put it here. So that's the token we want to deploy. So now what we are going to the interface we are going to use. Remember I said, the moment you create an interface, the compiler automatically creates a dispatcher for you. So this is the interface we created, we declared here. So I will just add dispatcher to it. I'll just come here, I'll remove this other guy, and I'll put it like this. So we have ERC20 combined dispatcher. The name of the interface is ERC20 combined. The reason why I named it like this is because it has the normal ERC20 functions and it has mint. So I just called it ERC20 combined. Yeah, you can name it anything. So I now added dispatcher to it. You see that here now I'm just using contract address because contract address, you get, instead of doing this and doing contract address again, is redundant. Instead of doing this, you understand, this will still work, but it's not necessary because they have the same name. So just leave it at contract address. Now, once you do this, let me get rid of all of this. So now you remember that in our constructor, we are doing this and this. So the only thing we need to do now, we just do, let's call this token. We just do assert that token dot name is equal to, let's pick the token name we used. It's equal to Bankers token. Paste it. You say wrong token name. Then you do this again. You now say assert that token symbol is equal to BNK. Equal to BNK. Or you just do wrong token symbol. Are you guys following? If you're following, thumbs up, please. All right. So here now we are just testing only the constructor, and this is a unit test. You can still separate this text to be different. You can still say test token name, test symbol if you want to, but I don't want to separate the test. I want everything to just be constructor. Let's just test the constructor in itself. So let's run our test. Let's do scarp test. The moment of truth. Let's see if it's going to fail or pass. Just taking time. This one is from Cairo compiler. Scarp. It's from Scarp. So let's wait for it. All right. You see that it's passing, right? All right. So that is for the constructor. If you want, that test is taking time. I don't want to do, okay, let's call BNG. It will fail. To fail. It's just that the thing takes too much time. Takes too much time. As Scarp takes a lot of time. So while this is still running, let's continue on to the next test. So the next thing we are going to test the total supply. So what I will just do, I'll just copy this guy. While that test is running, let's not wait for it. So I'll just copy this guy. I'll call it test total supply. Total underscore supply. So test total supply, we do this. We don't need to test name again because we already tested name. So test total supply, how do we test total supply? We have to mint first, right? So when we mint, we will now say, let's say, let mint amount be equal to 1, 1, 2, 3, 4, 5. You can just do underscore U256. So you can typecast it by saying U256 here. All right. So this is, so you see that test failed. Can you see it? Wrong token. See, it points the exact one that failed, which is the one we changed. Wrong token symbol, which is the token name worked. So let's put it back. So BNK. All right. So let's continue. So this is the guy I want to use. So the next thing I'm going to do now is I'm going to say, okay, there's a way, let me show you something. There is a way they do this. I want to just copy this thing from here. So there's, like I told you, there is so this is the person we want to mint to. Token recipient, contract address. You can, this is like a helper stuff to like get dummy addresses when you're working with test. So you just do this stuff. So now what I want to do is I'll now say token dot mint. Who am I minting to? Token recipients, right? How many token am I minting to token recipients? Mint amount. In this total supply function, I can test balance of, I can test total supply at the same time. True or false? So I minted to this guy. Now, you know, when you mint, the total supply will increase, right? So we can just say assert that token dot total supply total on that. Let me see if my my compiler is still working. So that token dot total supply is equal to mint amount, because that is the only amount we have minted. Else, tell them wrong token supply. That's all. Like this now, you notice that this is not a unit test. This is an integration test. Why? Because we minted first before testing supply. If it was only supply we were testing in this test, it would have been a unit test. But we first of all called mint, which is a different function, before we called total supply. Does that make sense? So this is an integration test. It's not a unit test. So I don't want to. Oh, this test takes time. This test takes time. But let's run it as carb test. So are you guys following? Are you seeing how we are progressing? How we are doing the test? It's making sense, right? All right. So let's go. All right. So while that test is running, let's move over to the next test. I'll just copy this guy because I don't want to write all those things from scratch. Move to the next guy. So sorry, I call everything guy. So instead of say let's go to the next line of, it's too long. Let's just call it guy. Short form. Everybody knows the guy I'm talking about. So this other guy now, we want to test balance of. We don't even need to do anything. See, this test and this test are the same. The only thing we need to do, just say token dot balance of token recipient. Assert that it equals to mint amount. Just say wrong balance. It's because I want to show you guys. So if it's me, if I'm the one writing this test, balance of total supply means all of them will be inside one text. There's no point separating it. You see that the setup for total supply and balance of are the same thing from here to here. They are the same. The only thing we changed was the assertion. Look at it, same thing. So you see that the test is passing. Total supply, look at it here, it's passing. Constructor passed. So we have done two tests. Let's run test again to see the third one. That's, oh, wait. Hey, yo, this thing was supposed to throw error. Sorry. You can't have two functions. My compiler has turned off. Yeah. If I close this thing and open it to you, oh, my battery is shut. A moment. Let me connect this guy. All right. Oh, what's happening? All right. So, okay. All right. So, Why is this guy shaking? So we can't have, let me close this guy. Sorry, my charger is misbehaving. Why today? You. All right, we good. Okay, so let me close this VS Code and open it again. So you guys see what I was talking about. That's cap for you actually. Does that a lot. So this guy is supposed to throw red, supposed to show error. Why is it not showing error now? We can't have this and this at the same time. Okay, yeah, expected. So you see that it's throwing error. The compiler is slow. What's doing this charger? So we now go test balance off. You see? So let's run the test again. Let me zoom in so you can see this guy very well. Close this guy. So scab test. All right. So while that guy is running, we are going to test the approve function. So that one is the approve function is quite big. So we are going to test the approve function. We are going to test the transfer function. Once we test the approve and transfer, we are done with ERC20 tests. You can test transfer from on your own. So let's wait for this guy to finish running so we can move to testing the approve function. Meanwhile, I don't want to keep breaks between the class. So yeah, in case people that are watching the recording, it doesn't look boring to them. So we need to keep talking. So I'm going to copy this test again. Okay, you see that the three tests are passing. So I'm going to copy this, paste it here. So this one, what we are going to test is test approve. Right? Test approve. And it still goes with the same stuff. So here we need two users. The first user is the one that is going to hold the token, and the second user is the one that is we are going to approve. So what I'll just do, I'll call this, let me duplicate this. So the first one, I'll call it token owner, right? And the second one is token recipient. So I'm going to change the address. I'll remove 1, 2, 3. I'll add 0, 0, 0 here so that the address will be different. So now, the first things first, we are going to mint token to the token owner. We are going to mint to the token owner the mint amount. Now, when we mint to, why is this one showing red now? We are minting to token owner. Is this not token owner? Why are you showing me red? This compiler. So mint to token owner. Then the next thing we are going to do now, we are going to prank the owner. Like we are going to mock the owner to call the approve function and approve the token recipient. Now, what we are going to do, there's something we need to import here. We call it start underscore cheat underscore caller address. And we need to stop it as well. Stop underscore cheat underscore caller underscore address. So those are the two things we need. Now let's go to this approve. Now we have mint amount, we have minted to owner, right? Now owner wants to now approve this token. Let's just call this token spender. Simple, so that we don't get confused. Let's call it token spender, right? So this is a token spender. So here, let's do something like a comment. Owner approves token spender. So let's create something called spend amount. Let's say let's spend amount be equal to, we don't want them to be the same. Let's do U256 equal to 500 underscore U256. Yeah. So owner approves token spender. Let's just do underscore to spend token. Yeah. So now let's hit here. So what we are now going to do, we are now going to say start. Let me copy. Start cheat caller address. Now, which contract do we want to interact with? We want to interact with the token contract address. This one. That's what we are going to pass first. Now, who do we want to mock? Which user do we want to mock? We want to mock the token owner. That's the person we want to be the one to call the function. Now, once we do this, inside here that we now say token dot approve. Who are we approving? We are approving token spender. And how much are we approving the token spender to spend? Spend underscore amount. Can you see this? So this place now that we are doing token.approve, what we are doing here is the person calling this approve function is this owner, because the owner has this amount of token. So we are ensuring that we are mocking the owner to call this approve function from this token. That is why you see that the address we are interacting with here is the token address. Then once you do this, you need to stop. Let's just copy this, put it here, and change this start to stop. Yeah, and when you stop it, all you just need to put is the contract address you want to stop the prank on. I think this should fail because the name of the function you're testing is the same with the previous one. Let's see. No, it's not now. This is approve, and the previous one is balance of. Or is when did you send this? Okay, I think it's been long you sent it. Yeah. So this is it. Now we have done this approve. Are you guys following? Is this making sense? So now what we are now going to assert is assert that token dot allowance. Allowance is what you use to check what if someone was approved. So allowance, first person is the token owner, because allowance takes in the owner and it takes in the spender. So this should return the amount that the spender was approved. And how much are we expecting it to return? We are expecting it to return spend amount. So what this is doing is it's asserting that the allowance that this owner gave to this spender is equals to spend amount that we declared here. Else we say wrong allowance. Are you guys following? Is this making sense? All right. So you go here, you run your test. Let's watch it. Let's watch it. Let's watch it. Let's watch it. You see that? You see how this thing is? It's not. I told Cairo is very simple. That is the simplest language I've written. Cairo. Very simple something. Do you believe that Cairo is simpler than Solidity? If you agree with me, thumbs up. Cairo is simpler than Solidity. I'm telling you facts. Solidity is hard. Solidity that you write one contract, that contract will have different vulnerability. You kind of contract hardly get vulnerability because it's borrowed from Rust and they already have their security checks inbuilt. It won't even allow you to write nonsense. But Solidity, if you don't have stack too deep, you will have, if you don't have stack too deep, you have contract size error. If you don't have contract size error, you have this one, just wahala. That is why there's diamond standard. There's no diamond standard in Cairo. Why do you think there's no diamond standard? Because Cairo is perfect. So you can see that all your tests are passing. Everything is passing, approve is passing. So the last test you are going to be writing is the test for transfer. We are going to test transfer. So paste it here. So to transfer, we have done all this setup from here to here, right? So we want to test transfer. All we just need to do is we are still going to prank the token owner. And we are going to say token.transfer here. And who are we transferring to? Let's just call this token recipient. Recipient. So we are transferring to the recipients and we are transferring transfer amount. I like to name my variables based on what we are testing so that it will not confuse people. This is recipient, this is transfer amount. So if you, even if I give you this code, once you're reading it and you're seeing the variable naming, you should already know what is happening. So we are still pranking this contract address using the token owner, and we are calling transfer. We are transferring to the token recipient and the transfer amount, and we are stopping the prank, the cheat here. Now, the assertions for this one will be different. Because we are doing transfer, we want to assert that the balance of the token recipient is equal to transfer amount, because that's what we transfer to the person. Else we say transfer, no, wrong TRF balance. No. We say transfer failed. See, as I'm thinking of the best statement that will communicate what you're doing, because these things to help. Transfer failed. The next thing we are going to do, we are now going to say, assert that balance of owner. Because when you have transferred, the balance of owner is supposed to reduce. Now say, assert that balance of owner is equal to mint amount minus transfer amount, because the mint amount is what the owner had before. When the owner now transfer, it's supposed to be mint amount minus transfer amount. You now say wrong owner balance. So are you guys following? Are you guys seeing how I'm setting up the test and how I'm writing my assertions? Is it making sense? Is it making sense? All right. So
Yeah,
let's
100. Yeah.
all right. So let's run our test again. Scab test. Let's see what's popping. So this is the last test. After this test, I'll give you guys rooms for questions. So we are not going to do the bank contract. That bank contract is complex, and before we finish it, we might have gotten to like 8 p.m. or 7 p.m. So we are going to stop here.
We don't mind if that's okay by you, sir.
Don't worry, I mind. What is happening? Something has failed. Test approved, defined multiple times. Oh, sorry. It's supposed to be test transfer. Yeah, test transfer. Yeah. You see, my compiler would have complained if it was working, because that compiler used to go off on its own. So let's run it again. So for those that have questions, oh yeah, it's time. While we wait for this guy to finish running the test, ask your questions so we can touch them before we proceed. Before we end, because we are done. There's nothing to proceed to again. Why compiler return off? Why compiler return off? Okay. So that's how the scrap that thing is problematic. It's heavy. So I think they have not been able to like make it will just stay and turn off on its own. And it's mostly in the test environment that it turns off. But in the normal contract environment, it doesn't turn off, just that it slows down. And I can't say it's from my laptop because my laptop is very fast. So you can see that we have how many tests? 5 test cases. 1, 2, 3, 4, 5. This is where you see all the tests. Test constructor, test total supply, test balance of, test transfer, and test approve. You see that everything is running, and you see the gas each of the tests costs. You see the constructor is the lowest gas because it's just reading. The total supply means first, it's higher. The balance of, I told you the balance of and total supply are the same thing. The only thing we are asserting is just 2 different. You see the gas 495, 495. Transfer is higher, this 571, and this one is 566. So you can see everything and everything and everything. So we good. Any question? Let me have it.
Okay, GM, so you actually explained a lot of things that were actually giving us tough time. So my question is, I have this idea of test-driven development, that is TDD, whereby first of all they will tell you that okay, if you are writing tests, the first thing is you should write the test first, then the test should fail, then you should write the test so that the test will pass. But most of the times, okay, since I've started Web3, even if we started with Solidity, we'll write the test, we'll write the function first before we write the test. So I don't know, is it that the test-driven development, it's not widely used in Web3? And the second question is, okay, like in Solidity, again, if we want to deploy a contract, we have a setup function where we just deploy it there once. But here in Cairo, it's as if you want to test a function, you will need to deploy the contract over and over again. So is there any way that you deploy the contract once and just make a reference to it, or you need to deploy it over and over just the way you have been doing?
Okay. First thing first, test-driven development. That thing is not applicable in this smart contract development. The reason is because the way you set up your test is dependent on the way you wrote your function. Does that make sense?
Yes, sir.
You can't just, the way you set up your test is tied to how you wrote your function. So the way, unless you have a picture of what you want to do, you can be writing tests first. I feel like it's faster to write your contract first and write tests after than you go and write your test, finish, and the test is failing. You now go and write contracts. After you finish writing the contract, come back and start updating your test so that it will pass. Ross, why now? It doesn't make sense. I know test-driven development in when you come to back-end services and all of that. But in this smart contracting, that thing is you're routing too much. Then for the other one about having that function where you call that deploy fixtures and the rest, your deploy fixtures actually deploys your contract, deploys that contract in each of the test cases, unless you don't know. What that function does is, this is what it does, that in your Solidity deploy fixtures. You know, for you to interact with the contract, you have to deploy it. Now, instead of in each of your test case, you're now writing this thing, deploy this thing before you start interacting with it. That deploy fixture is just there to handle the deployment and return all the contracts or argument that you need. So inside your test case, all you just need to do is call the deploy fixture and you destructure it to get all the parameters that you need from the deploy fixtures. That's the same thing we are doing here. That deploy function is serving as your deploy fixture. Then inside your test cases, you just call the deploy function and it returns the address for you. If I want to do this, guys, so that, let's say, if I want to do something, I can do this stuff. For instance, I can make this guy a top watch. I can make this guy a top, and I will make it to return the dispatcher. I'll make it to return this thing. Now, I'll come here. I'll make it to return, what is this called? I'll make it to return this dispatcher too. So instead of doing this here, I'll just come here. I'll do this here. I'll say, I'll just come here and do, I'll say, let's contracts. Okay, I've gotten contract address, don't worry. Yeah, no need to do let again. So I'll just do this. I'll do this here. Let's token equals to this. Then I'll just come here and do contracts underscore address, comma, token. That's all. Then inside here now, inside this place, inside all this place now, for somewhere like here, I'll just do this. And I'll do token here. Sorry. I'll just do this, comma, token here. So I won't need this anymore. Can you see it? Are you feeling it? The person that asked, can you see what I just did?
Yeah.
So this stuff now, there's no point even repeating that dispatcher again, because you already set it inside that deploy stuff, so you can always reuse it. That's the same thing your deploy fixture does. Does it make sense?
Yes, sir.
All right.
Thank you.
Any other question? Any other question?
Yes,
Okay,
sir.
question. In the Bankart token contract, the event has an attribute flat. Please, what is the meaning? Okay, that flat means it's just an attribute to specify that this thing is coming from a component. That's what it's just saying. Just like just like you have key. Key is telling the compiler that this this particular event is indexed, just like you have index in Solidity is an indexed event. So flat is like the same way you have sub storage that tells you that this is not the main storage, this is the sub storage. That flat is also like an attribute that signifies that this is coming from a component. Does that make sense? Yeah. Any other question?
Yes. Okay, so I'm back again. This address, is it that you can just specify any amount of numbers, or there is specific length that you need to specify? And when deploying the contract again, please, I don't know, can you scroll up? There was a particular place you were like unwrapping an array.
I'm coming. Let me just do this thing back where it was.
Yeah, this contract.deploy.
Yeah.
So the name, is it that it takes the name as an array and unwrap it? I don't actually get why we need to put it in an array first before unwrapping it.
I didn't get you.
I said this place that we are actually unwrapping an array. Okay. That
Where are we unwrapping the array?
Okay, contract.deploy, then add array trait, then new array.unwrap.
It's not the array we are unwrapping now. It is the deploy we are unwrapping, because the deploy returns a result. Whenever you make use of unwrap, it's if something is returning a result or an option enum. You understand? So if you know result is either it returns a value or error. Option enum to either return some or none. So you use unwrap whenever something is returning an option enum, and you know result is an example of an option enum. So declare and deploy will either return an address. Declare will either return a contract. What is it called? Contract class, or it's going to fail. So because of that, it's a result, and result is an option. It's an example of option enum. So you always unwrap, unless you want to handle the cases. So if you don't make use of unwrap, then you can now start doing things like match. For error case, you do this. For this thing, if it returns value, you do this. But if you don't want to go through all those processes, just use unwrap. What unwrap does, if it fails, it will panic. Does that make sense?
Yes, it makes sense.
All right.
Okay. And I said for the address, is it that you can just put any length of numbers, or there are...
So I think this is how it is. You can, what you're putting here is a felt. So you can, if you remove one now, you see it's wrong. But if you remove two, it works. Are you seeing it? If you remove this one, it's wrong. If you remove another one, it works. If you add this one, it's wrong. If you add again, it works. If you add this, it's wrong. If you add this, it works. So let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I think 1, 2, 3, 4, 5, 6, 7, 8, 9. It has to be 9 number or something. I don't know how they are doing it, but this is how it is.
Okay. Thank you.
Is there a way to read a .env variable in Cairo test the way we have in this? I've not actually played around .env. The only time I use .env is if I want to deploy, and I use TypeScript to write. I have the TypeScript script I wrote for deploying contract. So that's the only time I use .env. I've not played around it with Cairo. So maybe you can explore that. All right. Any other question? Okay. So I think if there are no other questions, I guess this is the end of the class. Who is the moderator? Yes? Yeah,
That's Ojoku.
my boss.
It's good to hear your voice, man.
It's been ages. You just went to Jos and you left us. You left us.
Don't be smart, you know.
Well, I like what you guys are doing at Blockfields. Makes sense. When I invite me come just make you catch me small.
Yeah, sure. We have you in our plans.
No, it's all good. It's all good.
Yeah, thank you so much for honoring our invitation. It means a lot.
Yeah, you're welcome. Always welcome.
Yes, I'm hoping that one of these days we are going to have you to not necessarily Cairo, but then some advanced smart contracts concept and stuff like that. But that will be only for the engineers of Blockfields Labs.
Okay, no problem. No wahala.
Yes. Yeah, thank you so much for coming.
Just keep me posted. We are good.
Yeah, sure.
All right, no wahala. All right.
Yeah, good night.
All right, guys. Bye, everyone.
Thank you,
Bye
sir.
now. Yeah, bye.
As you got about